Here we have three-digit numbers ABC, non-zero here. And we have this equality with repeating decimal. Here ABC with the bar means it repeats ABC, ABC forever. Now, same thing is true here, just A repeating forever, B and C. So we have this equality. We try to find how many such three-digit numbers are there. Okay, so you should know that for this repeating pattern here, for example, the way to figure it out is multiply 1000 on both sides. You can get this equality. When you solve it, you have whatever the number divided by 999. Now, similarly for single digit, you know that it's going to be 7 over 9. So we plug in the original equation. What do we have? From here, you know that that's going to be ABC as an integer, which is 100 times A, 10 times B, and C. Added together, that will be the number on the top, and on the bottom would be 999, this fraction. And here would be A over 9, B over 9, C over 9. Let's plug that in, right? So here you have 9, you can cancel. And this is a multiple of 3, you can cancel. Now you're going to rewrite this equality. And here you have multiple factor of 9. So get rid of 9 here. What you get is 7. This is going to be 3 and 4. Alright, that's the relation of ABC. Notice that ABC are non-zero digits. They're from 1 through 9. Alright, so let's look at this. There are three cases. One is B equal to C. In this case, this equation becomes A equal B equal C. So how many cases here? A can be 1, 2, 3, up to 9. So the total 9 cases here, right? So what if B is greater than C? Yeah. If B is greater, we're going to assume B equals C plus D. What is D? D is going to be a positive integer here, right? Because we assume B is greater. So which case here? Of course, for the digits here, at most, B can be 9. So D can be at most 8, right? It cannot be greater than that. So this is the range. Now we're going to plug that in to the original equation here, 7a. That would be 3c plus 3d here, this replaced, plus 4c. What you get is this. All right, but this, from here, this equation, you know that 7 must divide d. But then d, this range, there's only one possible value for d, that is 7, right? So from this equality, we know that 7 is a factor of d, so d can only take one value, which is 7. Now in this case, A minus c would be 3. Now notice, however, with that constraint, yeah, since b is 7 plus c, so c cannot be too big, right? C can only take two values, 1 and 2, right? So we have two cases, c, 1 and 2, and b is going to be 7a, right? So it would be 8 or 9. And a would be c plus 3, 3a, so it would be 4 or 5. Two cases here. Now similarly, the third case is going to be b is smaller, right? So in that case, c is bigger, so use the same trick. C is going to be b plus d, where again d is positive but less or equal to 8. Plug in the equality, what we get is this. Similar argument, we're going to get this. So we say that 7 must divide d, so d can only take one value again, that is d equals 7, a minus b equal to 4. Use the same argument since c is bigger this time, and b plus 7, right, cannot be exceeding 9, so b can only take two values, that's 1 and 2. So the two cases, b is 1 and 2, c is going to be 7 plus, it's going to be 8 or 9, and a is going to be 4 plus, it's going to be 5 or 6. Two cases here. So the total we have, when they're equal to each other, it's going to be 9 numbers. When b is greater, there are 2 numbers. When b is smaller, there are 2 numbers. The total is going to be 13 numbers satisfies the original equation. So that's the answer is D. Please like and share.